Happy Tuesday. We're in week 3. It's crazy. Um, hope you're all doing well so far. I hope it's not you're not struggling with the material. That standard deviation didn't hurt your feelings. Use that calculator. You don't need to do it by hand, so use the calculator. Today we're going to carry standard deviation a little bit further. Section 3.4, we're going to look at z-scores. And so we're not going to spend a whole lot of time on standard deviation. We're going to put mean and standard deviation in our pockets after z-scores. And then we're going to start looking at stuff that we can do with median. So everything after the z-scores is going to have to do with median. The very end, we're going to look at lab 2. I'm going to walk through that pretty quickly with you and answer any questions that you have. And that's what's going on today. So I had something else I was going to say also, but it left my brain. We will see if it comes back. If not, it probably wasn't that important anyway. I mean, it could have been, but whatever. All right. So let's go to 3.4. I think the assignment is 3.4/3.5, right? It's one assignment for both sections, I believe. Okay. All right. So let's jump right into what a z-score is. So a z-score is the distance a data value is from the mean in terms of standard deviations. So like when we draw, that's not a pen, let's get on a pen. So when we draw our curve, when we're looking at the empirical rule, we have our 68% is -1 standard deviation plus 1 standard deviation away from the mean. Then we have our 95%. That's -2 standard deviations or +2 standard deviations from the mean. So this tells us we know that 2 standard deviations above the mean and 2 standard deviations below the mean, everything within those two values is 95% of our data, or approximately. So what a z-score would say is that a z-score of 2 would mean that we are 2 standard deviations above the mean, or our data value is. So it's within that 95%. Or like a z-score of 1.5 tells me that I took the mean and I added 1.5 of the standard deviation to that mean, and that is where that data value is 1.5 standard deviations above the mean. So z-scores can be positive or negative. If it's negative, it's below the mean. If it's positive, it's above the mean. I'm going to erase all of this crazy stuff that I've got going on here. And then we'll talk about how we calculate it. So the way we calculate a z-score, population and sample, they're calculated exactly the same way. We just have different symbols. So you take your data value. So that's what this is. This is the data value. You take the data value, you subtract the mean from the data value, and then you divide by the standard deviation. So data value minus mean divided by standard deviation. And this will tell you how many standard deviations you are away from the mean. The reason we do this is because basically what it does is it standardizes it. It like brings everything to the same units. So it's kind of like if I decided to convert everything to feet, that way everything is in the same units. Or you convert everything to miles, or everything to pounds. So if I said, I have 50 ounces of flour here and I have a half a cup of flour here, it's really hard to compare those two amounts. So I would need to convert them all to the same thing. So I could convert them all to grams or all to cups. And that way we're comparing apples to apples. That's basically what a z-score does. If I have two different populations and I want to compare two things from the populations, if I get the standard deviation or the z-score, then I can compare apples to apples. And we're going to do that in a minute so you can kind of see where we're going with that. So you just take the data value minus the mean and divide by the standard deviation. So let's do some examples. So hopefully this will make sense. Okay, so here's the first one. So the average height of males 20 years or older is 69.1 inches with a standard deviation of 2.8 inches. The mean height of females 20 years or older is 63.7 inches with a standard deviation of 2.7 inches. So we got this from the National Health and Examination Survey. We want to know who's relatively taller. So obviously Kevin Garnett at 83 inches is definitely actually taller than Candace Parker, who is 76 inches. But we want to know relative to the average, who is taller, who's relatively taller, who's, you know, fewer standard deviations away from the average height. So I'm going to calculate the z-score for both of them so we can compare them and see who is relatively taller. All right. So the first thing, let me see here. So I'm going to take Kevin Garnett's height, 83, subtract the mean, which is 69.1, and divide by the standard deviation, which is 2.8. This is going to give me his z-score. So his z-score is, now if you put this whole thing into the calculator at once, make sure you put parentheses around your numerator. Otherwise, bad things happen and you won't get the right answer. So you'd put parenthesis 83 minus 69.1, close your parenthesis, then divide by 2.8. So I have a z-score for Kevin Garnett of 4.96. So Kevin Garnett's his height is almost 5 standard deviations above the mean. So anything that's more than 2 standard deviations above the mean is considered an outlier. So he is definitely an outlier. So let's take a look at Candace Parker. I'll take her height of 76, subtract the average, which is 63.7, and divide it by the standard deviation, which is 2.7. Once again, make sure you put parentheses around the numerator before you, or if you're going to put it all in at once. So her z-score is about 4.56. Once again, a z-score of 2 or greater, or sorry, greater than 2 is considered an outlier. So any value more than 2 standard deviations from the mean is an outlier. So she's still an outlier. She's 4.5 standard deviations above the mean, but she is still relatively, Kevin Garnett is still relatively harder or taller compared to the average because he is almost 5 standard deviations above the mean and she is 4.5 standard deviations above the mean. So relatively, Kevin Garnett is taller. Questions? All right, we're going to do another example. I'm going to have you all try this one, try to work it out, and I'll work behind you. So let's talk about this. So we're going to determine whether the Los Angeles Angels or the Colorado Rockies had a relatively better run producing season. So the Angels scored 773 runs, and their average is 677.4 with a standard deviation of 51.7. The Rockies, they scored 755 runs. Their average was 640 and standard deviation of 55.9. So remember, it's x minus mu divided by sigma. So go ahead and start. I'm going to work after you quietly. After you get going, I will calculate it behind you. It's weird. How'd we do? Give you a second. So I got that the Angels have a Z-score of 1.85. The Rockies had a Z-score of 2.06. So the Rockies, their score was so good that they are an outlier because their Z-score is greater than 2. The amount of runs they scored are more than 2 standard deviations away from the mean. Therefore, they're an outlier. And while the Angels did really well, they're 1.85. That's really well. It's still a very good season, but relatively, the Rockies did better. Even though the Angels scored more runs, relatively, the Rockies did better. Questions? So we have a test next week, as you probably all realize. I'm sure you saw that in my email. Um, After the test, after I grade the test, I always post the mean, the median, and the standard deviation in the forum for everybody to look at, and you can calculate your own Z-scores. So you can see where your score landed in relation to the rest of the class. It's kind of a fun thing once you know what's going on, being able to look at that and say, oh, look, my Z-score is 1.3. So that means I did a little bit better than the average of class. So it's kind of fun to do that. And I try to do that after every test. So it's kind of a fun little thing. Once you know what's going on, it's cool to have those kind of numbers. Questions about Z-scores before we move on? All righty, I'm gonna move on then. So now we're gonna jump. So put standard deviation and mean into your pocket. We're now using the median. We're gonna use the median from here on out. We're gonna learn the median's answer to standard deviation. So put those standard deviation and mean into your pocket. We're going to talk about quartiles. All right. So the diagram is probably a better explanation than the words. So in your notes, I would make sure that this diagram is there and clear because it makes a lot more sense than all of these words. So all quartiles are is the places the points in your data that divide it into quarters. So for example, we know that the median is smack dab in the middle of all of your data. So 50% of the data is above the median, 50% of your data is below the median. So we know the median is smack dab in the middle. So Q1 or quartile 1, the first quartile, it is pretty much the median of the bottom half. So after I find the median, I find halfway between the smallest data value and that middle value. So halfway between them. So it's kind of the median of the bottom half of your data. That's quartile 1. So it splits the data. 25% of the data is below Q1, 75% is above Q1. This diagram does a pretty good job of showing it. Quartile 3. So you have the top half of your data, so above your median up to your largest data value. Quartile 3 is halfway in between. So 25% of your data is going to be above quartile 3, and then 75% is below quartile 3. Once we do an example, it'll make sense. So this diagram right here is a super good representation of that. Okay. Let's go on and do an example. This tells you how to do it first. So the first thing you want to do is you want to take your data and you want to arrange it from smallest to largest. And then you're going to find the median. The median is technically quartile 2, but we almost never call it quartile 2. We just call it the median. If you call it Q2, there's nothing wrong with that, but people rarely call it that. So now after you did that, you divided your data set in half, and 50% is below and 50% is above. So then to get the quartile 1, you find the median of the bottom half of your data, the median of the data below your median. That will be Q1. Then the median of the data above the median will be Q3. And that's it. That's all there is to it. It's actually fairly simple. So I'm going to jump to the next screen. All right. So this right here is so a group of Brigham Young University students collected data on speed of vehicles traveling through a construction zone. The posted speed limit was 25, and the recorded speed of 14 randomly selected vehicles is given below. I put them in order from smallest to largest because I didn't want to deal with doing it now together. So I already have them in order from smallest to largest. So first thing we're going to do is we're going to find the median because we're going to find quartile 1, the median, and quartile 3. So we always find the median first. There are 14 cars. So we're going to find our median between 7 and 8. 1, 2, 3, 4, 5, 6, 7. So our median is smack dab right here. It's 32.5. This is my median. So the median is right there, smack dab between 32 and 33. So it's 32.5. All right. So now, in order to find Q1, I am going to find the median of the data values below our median. So I have 7 values that are below the median. So it's going to be the 4th value. So it'll be this one right here, because that is smack dab in the middle of the bottom. So this right here is my Q1. Once again, I need to find Q3. I need to find the median of the top of the data value of the data. So it'll be the 4th one above the median. So it'll be this one right here. This is Q3. Now, all it's asking by saying to interpret, it just wants me to say that 25% of my data is there, 25% is here, 25% is there, and 25% is there. That's all it's asking. That's it. It really doesn't get much more complicated than that. It's pretty simple. Questions?
Yeah, so if you were to draw like little brackets, would the 28 go with the Q1 or would the 28 go with the second quarter?
Yes, that's
Okay.
all I got.
Okay. Thanks.
On the cusp, so it doesn't. It's kind of like the median. It's just that middle value. Yeah, it's ambiguous. But they because they like say that basically this is less than or equal to, but then all of this is greater than or equal to. So it's kind of ambiguous. It's not. Statisticians don't deal in absolutes. Yeah, sorry, I wasn't more helpful than that. I was waiting for that question. All right, let's move forward. Okay, this was my interpretation. 25, see, less than or equal to. 25 of the percent of the speeds are less than or equal to the first quartile. So I guess technically the below goes with it, but it's really ambiguous. 50% of the speeds are less than or equal to 32.5, 75% are less than or equal to the third quartile, and 25% are greater than. So, I mean, technically, I guess you could say it goes with the below, but I we really try to make sure not to ask any questions that make you make that decision, if that helps. Okay. So this is like the data we're going to use for most of this lesson. So this is highway loss data. And once again, I put it in from smallest to largest. So the Highway Loss Data Institute collects data on collision coverage. So people get into an accident or something happens, and this is how much money was paid out for whatever the damage was. So I would like you to find there's 18 data values here. I would like you to find the median, quartile 1 and quartile 2. So Q1, find Q1, the median, and Q3. Go ahead and find those values. There are 18 values here. I'm going to work quietly behind you. So if you don't want to see answers, don't look up. How'd we do? I got a Q1 of 735, a median of 1805, and a Q3 of 4668. So 25% of our data is less than or equal to 735. 50% of our data is less than or equal to 1805, and 75% of our data is less than or equal to 4668. So it doesn't mean that, I mean, obviously this goes up to 21,000. This isn't mean because mean would probably get a much higher value because notice how large those large values are. So we'd probably get a much higher value if we were using mean. But with median, it's just that middle value. So real quick before we move on, I want to jump to the calculator. I'm going to go back to the speed data because it's fewer numbers to put in the calculator. So I'm going to go to the speed data and we're going to put this into the list of our calculator. Let me find my calculator. Here we are. So go ahead and click on Stat and Edit. So we're in our lists. Hopefully you've practiced this enough with your homework. You're starting to get a little bit comfortable with it. And go up to your L1 and hit clear, enter. Remember, don't hit delete, hit clear, enter, so that we get an empty list. And I'm just going to type in the speed data from the Brigham Young University guys. So I'm just going to type that in. Give me a second to get all those in there. All right, once you get them all in, we're just going to go to the one variable statistic, so one bar stat. So you hit stat, arrow over to calc, and we want this first option. I already have L1 in my list. Leave the frequency list blank. Go down to calculate. Now we've already been here. It shows us that the mean is 32.14, which I don't care about right now. Standard deviation, if it was population, it'd be 6.18. Or sorry, sample is 6.18, population 5.95. I don't care about that right now. What I do care about, when you scroll down, you get Q1, which we already calculated that to be 28, median 32.5, that's what we got, and Q3 is 38. It also gives you the minimum and it gives you the maximum. So all of these values are super helpful, and I'm going to give you reasons why it's super helpful even more in a couple of minutes. But this is really useful. So this is on the same screen where we can calculate mean and standard deviation. You can get your median and your Q1 and Q3. So it's all right there for you. So I just wanted to point that out because it's helpful. because I don't, you're going to get some data sets in your homework where you're not going to want to write them out and order them from smallest to largest. It's so much easier just to put it in your calculator. All right, let's go back to where we were. Okay, so let's talk about interquartile range. So, oh, any questions about quartiles and median and all that stuff? So, right now, before we move on.
I have a question. If you enter like a data set into your calculator and it's not in order, like this last one we did, we kind of did the numbers in order. If you did them out of order and did the whole Veristats thing, would it still
Mhm.
enter the information the same? That
Yep,
part doesn't matter.
it'll still find it. It'll find it.
Okay, cool.
Yeah, it doesn't matter how you enter it in. We just happen to have data that's already organized. When I got it off of the when I originally was given the data set, it was not in order. And every single time I messed it up trying to do it myself, especially the highway loss data. That's a real big pain to put in order. This one right here, that was a real big
Yeah.
pain to put in order. So I'm like, you know what? My slides are just going to have it in order from now on. I don't think your slides have them in order, do they?
Um,
I
this
don't,
one's, I don't know. Yeah.
They
this
have
not,
it both ways. They have practice and then practice. They have out of order and then in order.
oh, okay. So I must have added the extra slide in there because I was like, okay, let's put them in nice and order. All right. So we're going to talk about interquartile range. So interquartile range is basically median's answer to standard deviation. Kind of gives us a little bit of the spread. It tells us the range of the middle 50% of the observations. So we usually just say IQR instead of interquartile range. We usually just call it IQR, it's its shortened name. And it's the middle 50% of your data observations. So you just take Q3, you subtract Q1 from it, and that gives you your middle 50% or your IQR. So when your homework is asking you to calculate the IQR, that's what it wants. Just take Q3 minus Q1, and that's your IQR. So much easier to find than standard deviation, isn't it? So much easier. It's not quite as useful as standard deviation, but I mean, it's still a nice tool. So of our speed data, you take the Q3 was 38, Q1 is 28, so you just subtract them, 38 minus 28. Our interquartile range is 10. So my Q1 and my Q3 differ from each other 10 miles per hour. That's our middle 50% right there. It kind of tells you about how spread out they are. So with that, I'm going to do, yeah, we'll do that in a minute. Okay. So I'm just going to kind of show you why we choose median when there's outliers. So suppose a 15th car traveled through the construction zone at 100 miles per hour. So let's take a look at what it does to the mean, median, and standard deviation and our interquartile range. So the original data, our mean, as we saw in our one of our stats, is 32.1 miles per hour. Once that 15th car went through, that 100-mile-an-hour car, our mean went up to 36.7 miles per hour. So it jumped almost 5 points, about 4.5 points or miles per hour. The median, on the other hand, it went from 32.5 to 33, barely affected by that 15th car. The standard deviation was 6.2 miles per hour, and now it jumps to 18.5. The standard deviation changed by 12 miles per hour. That is a huge difference. The interquartile range, on the other hand, went from 10 miles per hour to 11 miles per hour. It's barely affected. So the outliers are barely affect median and IQR. That's why if we have a data set that has outliers, we will usually tend to go use median instead of mean. Like for example, housing prices. When you probably see that they talk about median housing prices in different areas. And they do that because if you have like a foreclosed homes in the area that they're selling for super cheap, or if you have multi-million-dollar homes, they're going to skew that mean like crazy. But median gives you a better idea of what middle America is paying or what the average home price is. So sometimes median is a better way to deal with it. So if your distribution is symmetric, if it's a nice bell shape, we generally use mean and standard deviation. If there are outliers, if we're skewed left or right, then we usually use median and interquartile range. So you just have to make that decision for yourself based on the shape of your data. So once we get to final projects, which not sure if it's a week or 2 weeks that I give you that project, so you can start at least thinking about it. Um, you'll once you start working on it, you'll have to make that decision on your own on whether, is my data skewed? Should I be using median instead? And we're gonna compare, and you'll see. We've got lots of stuff going on. All right, moving on. So let's talk about outliers. We've already established that when we use mean, anything more than 2 standard deviations away from the mean is considered an outlier. So anything outside of that 95% on our empirical rule drawing, anything outside the 95% is an outlier. So more than 2 standard deviations away, it's an outlier. When we are dealing with mean or median and IQR, this is our rule right here. This right here, I'll explain in a second. So you take quartile 1, so whatever your quartile 1 value is, and you subtract 1.5 times what your IQR is, and you'll get a value. Anything lower than that value will be an outlier. Then you take quartile 3 and you add 1.5 times whatever that IQR is, and then anything higher than that value will be an outlier. So these are called fences. When we create the barriers, those are fences. So anything lower than the lower fence or higher than the upper fence are outliers. We're going to do examples and hopefully that'll help. I'll give you a second to write things down. I'll drink my tea. It's getting hot in my house, but I refuse to turn the air conditioning on in April. I refuse. So I'm letting my house get hot. When you're there with me, like I will not do it. Classrooms at my school are terrible. It's been hitting 80 degrees in our classrooms. It's awful. We have no AC in the class. Kids in the afternoon are wearing their hoodies and they're complaining about being hot in the class. Like I refuse to listen to anybody complaining about heat that's wearing a hoodie. I won't even listen to it. All right. So let's take the speed data. So our first and third quartiles are 28 and 38. Our interquartile range, our IQR, is 10. So I take I have it here, but for some reason when I write it down, even though it's typed out, writing it down helps it stick in people's brains. So you take Q1, which is 28, minus 1.5, and then this is the IQR. IQR. And then this right here is Q1. So 28 minus 1.5 times the IQR is 13 miles per hour. This right here is my lower fence. Anything lower than 13 miles per hour would be an outlier. Now I'm going to take my Q3. So Q3 is 38. That's Q3. Plus 1.5 times 10, which is once again is the IQR. And that's going to be 53 miles per hour. This right here is my upper fence. Anything higher than the upper fence is an outlier. Now, I don't have any values that are lower than 13 or greater than 53. Therefore, I have no outliers. I do want to give you a little warning though. Because we're on one sense we're dealing with median and the other sense we're dealing with mean, when we're dealing with standard deviation and mean, it is possible to find an outlier when you're dealing with mean and standard deviation, but not find it on median and IQR or vice versa. It is possible. So it's kind of like whatever I'm like working with at the moment, whichever thing I am working with for my project or for whatever situation, that's the one I'm going to rely on. So like in this case, I'm dealing with median and IQR. That's the only thing I'm dealing with. I'm not going to jump over and check the two standard deviation rule. I'm not going to check that because I'm dealing with median and IQR. I think your homework wants you to find both. Your homework will say use the 1.5 IQR rule. This is what you would do. Then it would ask you to also use the two standard deviation rule. That's when you're going to use mean and standard deviation. Okay.
So are we not counting that guy who blew through at 100?
What was that?
Are we not counting that guy who blew through at 100?
No, we're not counting him. His I thought did it not say that? No, we're not dealing with the 100-mile-an-hour guy. He was just there for that one question.
Okay, because he would be a clear outlier if we did.
Exactly. Even with our 11 as our IQR instead, he would definitely be an outlier. Yep, good question. Okay. Now we're going to use the collision loss data. So I'm going to write down because you probably don't have this super handy. Q1 was 735. Q3, and my handwriting is extra bad today. Q3 is 4668. And so go ahead and find your upper and lower fences. So remember, it's Q1 minus 1.5 IQR and Q3 plus 1.5 IQR. Okay, I'm going to give you a second and then I'll work quietly behind you. And it is okay to get a negative number. Nobody's going to get mad about it. Oh, our IQR. I mean, I guess you could probably calculated that, but I'm going to write it right here. All right. So I have a lower fence of negative $5,164.50. And then I have an upper fence of $10,567.50. So we clearly do not have a lower outlier, but I do have a data value. Our highest data value is $21,147. That is clearly an outlier because this is higher than my upper fence of 10,567.50. So that one is an outlier. Questions? So far, so good. All right. Move on. All right. So now we're going to take it down to the nitty gritty. We're going to we are going to do something called find something called a 5-number summary. So 5-number summary is super helpful when you have a large data sets. Because if I have like 50 or 60 data values in my data set, I'm not going to want to sift through all of those numbers. So I can pull just the important numbers out of them and call that my 5 number summary. So the 5 number summary is as follows. It's the minimum value, then quartile 1, then the median, then quartile 3, and then the maximum. You don't have to label them at all. If you are giving me a 5 number summary, you just list those 5 numbers and list them in that order, and then I will know what they are. So if I say I have a 5 number summary, it's 12, 18, 23, 35, and 80. I know what each of those things are. You just list those 5 numbers out, and I know that that middle number on it is your median. I know the second number on it is the quartile 1. I know the lowest number is the minimum. So it's listed basically exactly how it is right here. You see here. The nice thing is whoa, your calculator gives you the 5 number summary right down here. Gives you minimum, quartile 1, median, quartile 3, and max. This right here, these 5 numbers are your 5 number summary. If I ask for your 5 number summary, you just list these numbers. You don't have to list what they are. Just list them in that order. List them 20, 28, 32.5, 38, and 40. Just list those numbers. That's your 5 number summary. Okay, let me go back to my other screen. So the 5 number summary for the speed data, we just had that. I'm just going to pop back here again. Just going to write it on my screen. 20, 28, 32.5, 38, and 40. Most of the time, this is all you need. Most of the time, you're not going to need to actually sift through the rest of the data. This right here will answer all your questions. So you would just give it to me like this. Just write those 5 numbers. So of the summary of the collision data, we have our lowest value for the collision data was 180. Then my Q1 is 735. My median is 1805. Q3, 4668. And my maximum, 21,147. So I have my Q1 and Q3. So if I needed to find, if I needed to try to find if there's outliers, I can see if there's outliers or not. With having that maximum value there, I would be able to tell that we at least have one outlier. So this is most of the time, all of the data you need is your 5 number summary. And so you need to know also that if I tell you I'm giving you a 5 number summary, this is what I'm giving you. Minimum, Q1, medium, Q3, and maximum. I'm going to tell you in your homework, there is a question where they tell you, actually, I'm going to pop over there real quick. It's going to be more helpful. Let me get to that screen. Get to your my open math. It's going to be much more helpful if I just jump there. My teacher preview. So there's this question here. Your numbers will be different than mine. This question right here. They give you the 5 number summary. This number, the 2 is the minimum. 4 is your Q1. 7 is the median. 16 is Q3. And 20 is the maximum. So use these values. So don't try to find a median and a Q1 and a Q3. It's all right here. This is a 5 number summary. It's not the complete data set. So be really careful with that when you get this question. The most common error here is people are trying to find like the median of this as a complete data set and the Q1 and Q3 as if this is a complete data set. It's not a complete data set. It is just a 5 number summary. So be really careful with that. All right, questions about 5 number summaries before we move on?
Yeah, so the bottom 5 number summary, they were actually dollar amounts. Is a 5 number summary like unitless, or would you technically want to put dollar amounts?
It doesn't even matter. I mean,
Okay.
I know their dollar amounts. If you want, if you want to be completely accurate, dollar amounts might be helpful. I wouldn't personally mark you down for it, but it's probably more accurate that way. Unless I said make sure to include units, that I don't really care. But that was a very, very good question. But I think putting miles per hour on the top one might be clunky. Don't you agree it would be kind of clunky to have those letters in there? So whatever you choose to do, you go for it. I'm just going to grade you on whether or not you give me those 5 numbers. I'm not going to care if the units are there. So they're not unitless. It's just they're more like numbers I can work with rather than so this is like the showing your work part of doing math is I'm going to pull this out of my data set so that I can answer all the questions I need to answer. So this would be kind of like um, the middle part of your work before you get to your final answers, if that makes any sense. Even though I might ask for this middle step, it's kind of like with this question back here. I found my 5 number summary. Now they want to know where am I going to find outliers? So this right here is your like final answers. This is like what you're working with, I guess. Okay. All right. We're going to talk about box plots. Now, I'm going to tell you right now on the test, you will be required to draw a box plot by hand. I'm going to give you every little bit of information that you need to draw a box plot by hand. I'm going to tell you all of the things I expect to be on your box plot. So you before the test, maybe watch this little piece again, or you can watch it on the pre-recorded video. I think the box plot has its own video on the pre-recorded videos, but I'm letting you know there will be a box plot that you need to draw by hand on your test that you're having next week. So when we draw a box plot, the first thing you're going to do is you're going to of course, you're going to find your your median, your Q1 and your Q3. And then you need to find your fences. So the upper fence and the lower fence, we need to know where those are. You're going to draw a standard number line. We're going to do one of these together, don't worry. You're going to draw a standard number line. Now on your number line, you're not just writing the data values in. It's a standard number line, and you want to make sure that it's long enough to contain your entire data set, but it's just kind of a reference number line. Then we're going to label the fences and you'll see. The box part of the box plot. The bottom of the box is going to be Q1. The top of the box is going to be Q3. And there's going to be a line in the middle to represent the median. Any outliers we have that are outside of the fences are going to be represented with an asterisk. This is going to make so much more sense once you see it and once we draw it. But this is just kind of like the step-by-step pieces. Okay. The data that we're going to look at right now is credit card interest rates. And we're going to construct a box plot with the data. Actually, it's just going to be here. Here's the data. And here is my box plot. So notice that my interest rates are all decimals. 14.3, 13.3, there's a couple whole numbers. But look at my number line. It's just a standard number line. It's just standard number line. So my lower fence is at 8.4. My upper fence is at 18%. So I have these they're like square brackets that I put for my fences. And I have an asterisk because I have an outlier. My outlier is at 6.5%. So I have an outlier of 6.5% right there. It's an asterisk. These whiskers, they go to the last data value inside the fences. So most of the time, your whiskers are not going to go all the way to the fences. They're going to go to the last data values inside the fence. This right here, this is Q1. This is Q3. And this is the median. Notice that there's nothing labeled on the box plot itself except for what I just drew in for you. but we don't really label anything with numbers. It just kind of hovers over your number line. And it really annoys me, but on Excel, the box plots are vertical, and it really annoys me. There's nothing wrong with it, but I just don't like it. They're ugly. We're going to do one together with the highway loss data. And I think doing it together is going to be where all of the learning is going to happen. Like 99% of the learning about box plots is going to happen by us drawing one together. Okay, does anyone need another moment right here? Okay. So we have a nice clean page right here. All right, so when it comes to the number line, I only know the increments to make on the number line because I've taught this a whole lot of times. The first couple of times I drew this number line, I had to erase it and change the scale because it took a while to get this. So I'm gonna use black. I'm gonna draw my number line. Let's draw my number line. Be nice and pretty. Okay, there's my number line. I am going to count by 500s, but I'm going to only write the thousands in. I'm going to start with a 0 right down here. 0, 1,000. I'm just going to do this all the way across. I'm going to show you a little trick because that can be tricky. Okay, so I'm going to go to 11,000. So after 10,036, our next data value is 21,147. So I'm going to do something called putting a break in the graph. So if you're like basically wanting to take a big chunk out of the middle of your graph because you don't want to like all this empty space, you don't want to I don't want to write 12,000, 13,000, 14,000, 15,000, all the way up to 21,000 because that's just a lot of empty space that we're going to be using, right? So this is a break in the graph. So you just put like a squiggle line there, and that's just telling me I'm taking a big chunk out of my graph, like a big chunk of uselessness in my graph. That's just what I did. I broke my graph. So now put my black pen back on, and now I'm going to start at 21,000. I'll put 22,000 here just to, uh-oh. There we go. So I just broke my graph. That way I don't have to keep writing all the way down there and it would just be a big pain. So that's what I did. I broke my graph. All right. So I know it says to put the fences in first, but I just don't like to put the fences in first. I'm going to do the box first. And it doesn't matter which order you do them in as long as you do them right. It doesn't matter. So the first thing I'm going to do is I'm going to make a vertical line where my median is. The median is at 1805. So you just find an approximate spot. And remember, your box just kind of hovers above your graph. So I just put a vertical line approximately at 1805. We're not measuring or making it perfect. This is really approximate. Then I need Q1. Q1 is at 735. So I need to just go down here and approximate where I think 735 is. That's right about there. And then my Q3 is at 4668. So I'm going to approximate where that is. And it's not perfect, but I'm going to move this one down a little bit because this one's a little high. And I have that ability. Okay. Then you're just going to close your box in. This is the box. That's the box. I don't care if it's perfect. You just do the best you can. Okay, now I'm going to represent my outliers. I'm going to do the top one first because it's kind of the easiest. Or I mean, not the outliers, the fences. My upper fence, we calculated this. The upper fence is at 10,567. So I'm going to come up here and I'm going to put a square bracket right there. That's my upper fence. Now, when my lower fence is something so ridiculous like negative 5,164.5, usually your lower fence is going to land on your graph, but this one is kind of ridiculous. So I just kind of stick it over here. Just stick it over here off the edge. And it doesn't matter if you want to, you're more than welcome to label it. If you want to label it like that, you can. Otherwise, if you just stick it off the graph, I'm going to realize that this is just a completely ridiculous out lower fence and call it good. So label it, don't label it, I don't care. Okay. Our last piece. Our last piece is we want to do our whiskers. The whiskers go to the last data value that is inside the fences. So my lowest value is 180. So I'm just going to draw, whoop, I'm just going to draw my whisker, approximate where I think 180 might be. I don't know, that might not be far enough, but I'm going to make it a little bit longer. Let's make it a little bit longer. Here we go. I don't know. It might not be long enough, but it's close enough. Okay. And then my upper whisker is going to go to 10,036. So 10,036 is my last data value inside the fence. So it's right about there. Whoa. There we go. I have these fun tools that make them nice and pretty. So it's right about there. So most of the time, your whiskers will not go all the way to the fences. Every once in a great while, they'll go to the fences, but they don't go to the fences. And our whiskers never go through the fences, never, ever. The very final thing that we're going to do is we need to represent our outlier. We have an outlier at 21,147. That's going to be an asterisk. So I'm going to draw that right there. There's my outlier. And that's it. This is our box plot. It's box plot or box and whisker plot. Those mean the same thing. If I just say box plot, it means this. If I say box and whisker plot, it means this. They're the exact same thing. One of them is just shorthand. All right. So now is when you ask me questions about what we have here, what we just did together, because you will need to create one of these on the test. This is a really good notes that you just created that if you have this with you, that this will be super helpful on the test, right? Especially this one also. This one right here where I labeled that, that's helpful too. Notice I don't have labels on my Q1 median or Q3. I don't have labels on that. I don't want labels. I don't want the data values labeled in your number line. This is what it should look like. All right, I'm going to be quiet so you can ask me questions. Okay, that's it. So I'm going to show you here. So we try not to use, we don't frequently use box plots to describe the shape of the distribution because they're not 100% accurate, but they're a nice kind of rule of thumb, like to investigate a little bit better. So this one right here, you can see the whisker on the right is much longer than the whisker on the left. So this one is skewed right. This data is skewed right. You can see here, there's one similar to that, skewed right. The middle one is symmetric when the whiskers on both sides are about the same, and your median is like smack dab in the middle of your box. That one is symmetric. If your median is more to the right side of your box and your left whisker is longer, that's left skewed. Notice how the median is like on ours, the median is more to the left of our box. and then our whisker goes off to the right. So this is clearly skewed right. Right, so that's the last of the material before the lab. So any questions we have about the material that we learned tonight, not including the lab, which we're going to do in a minute. Okay. I'm going to set aside my iPad. And we are going to take a look at the lab. So we're going to do lab 2. So I know that um, some people's Excel is different than mine. So I have 2 different versions of Excel. I have my PC has a different version than my MacBook. So I'm going to show you both ways of finding the tool that we're going to use tonight. I believe there's even a third way, but I don't have that on any of my computers. So if we encounter that, I can help you figure it out if yours happens to be different than mine. I can kind of help you figure that out. But we're going to jump over to lab 2. So I took my continuous data, and there's a ton of it because this is what I do. You only need 20 data values. So if your continuous data was good and continuous and you had at least 20 data values, you can use it here. If you didn't have at least 20 data values, you're going to need more. Make sure that you don't get marked down for that. I think everybody did. I can't remember. I'm an old lady. I forget things. Plus, late Tuesday afternoon when it's hot, I forget things. So the first thing that we're going to need is we're going to need a data analysis tool. So on mine, this is the Excel on my MacBook, and not all MacBooks are going to have the same Excel. I don't know why some are different than others, but anyway, when up here at the tabs on the top, if I click on data, over here it says analysis tools, but there's nothing else here. So I'm looking for something that says data analysis. It's not right here. So if I click on analysis tools, this pops up right here, and I need to enable the analysis tool pack. So I'm just going to click the checkbox, and then analysis tool pack is there. And I click OK. Now I have data analysis. That's the tool that I'm looking for. I'm going to switch off of this, and I'm going to show you how to enable it with a different type of Excel. So I'm going to quit sharing my screen. I'm going to share on my other computer. I don't think you can hear me on my other computer, but you should be able to hear me across. So let's share a second here. Okay, let's share the screen. Okay, now I'm on my other computer here. All right, let me make this bigger. Hopefully you all can see this. Okay, so once again, when I click on data right here, over here on the side, wait, hold on a second. Make it smaller. Okay, there we go. Why am I having issues? Okay, so over here on the side, this is empty. There, over on the far right, there's no tools there at all. You can see that it's just blank. I need the data analysis again. So here I click on File, and all the way at the bottom, way down here at the bottom, it says Options. I'm going to click on Options, and this pops up. Click on Add-ins, then Manage Excel Add-ins, and click on Go. Once again, I'm going to enable both of these, the Analysis Tool Pack and the Analysis Tool Pack VBA. So click on both of those. Well, I don't want that one. Click on Analysis Tool Pack and Analysis Tool Pack VBA and click OK. And now I have the data analysis tool. I'm going to do that one more time because that's lots of clicks. Click on File, all the way down to Options. You have Add-ins. Click on Add-ins. Then Excel Add-ins, click on Go. And you want the Analysis Tool Pack and Analysis Tool Pack VBA. And then I'm going to click on OK. And then this data analysis will pop up. I'm going to unshare my screen and go back to the other computer. All right. Now that we're here, now that we're back, And now that I have the data analysis tool, we are good to go. Okay. So I'm going to click on data analysis tool, and what I'm looking for, I'm going to scroll here. What I'm looking for is descriptive statistics. I think even it says right here, place descriptive stats in this box. So I'm looking for descriptive statistics. When I click OK on that, I get this box right here that has a whole bunch of different options. So the first thing I want is the input range. This is where my data is. So you're going to click on your first one, hold down your left click, and then, or just if you're on a touchpad, just hold it down and you're going to highlight everything, your entire data set. And it's going to tell you that's the range. So it's from this column is A. So it's A4. So my first one is in A4 all the way down to A140. Okay. My output range. So I'm going to click on output range and I want it to end up in this box. So I'm just going to highlight this box because that's where I want it to land. I want all the stuff I do to land there. So you just click and just drag to fill this whole box. Okay. What I'm looking for is summary statistics. So check the box that says summary statistics. This is it. This is all we do. You do the input range, the output range, and summary statistics. Now I'm going to click OK. Make this bigger so we can see it. And this gives you, basically, this is like your one variable statistics on your TI-84. Take a look here. So I have the mean. Here's the median. This is the mode. Here's my standard deviation. And I don't care about anything else in here. I mean, maybe maximum and minimum. I don't care about any of the other stuff here. I just care about mean, median, mode, standard deviation, and then maybe your minimum and your maximum. That's all I'm going to care about in here. I want you to use Excel tools to fill in these boxes. I want you to use the Excel tools to fill in these boxes. So on mean, whenever you're going to type math in Excel, you have to put an equal sign first. When you put the equal sign, you're telling Excel, math is going to go here. Or you're saying, I'm going to reference another box or something like that. So you're telling it that you're going to give it a command. So when I put an equal sign in there, I'm telling it that I'm going to give it a command. So what I'm doing here is I'm going to say, I want this box to have data from another box in it. So I said equal. Over here, I'm just going to click on the mean value, so the mean that I have over here in my descriptive statistics, and then I hit enter and it will populate it. Same thing with standard deviation. I click on equal and I want to click on the box that has the numbers I want. So click on that and hit enter and it will populate it. I'm going to come back to number 2 in a minute. We're going to come back to that. The median, once again, click on equal and go over here and click on the box that has it, hit enter. Mode is the same, equal. Well, oh, that's not an equal sign. Equal, mode, enter. So I want you to use your Excel tools. I know you can easily just type these in here, but the whole idea is for you to learn how to use your Excel tools. The mean and the standard deviation. Look at how many decimal values there are. I don't want to type all those in. So much easier just put equals in that. Obviously, median, it would have been easier to just type in 7, but the point is to use the Excel tools. Okay, once again, I'm going to leave number 4 alone for now, and we're going to do the rest of our stuff for number 5 and 6. So the low, that's my minimum value, equals minimum, enter. I'm going to go down to the high value, equals maximum, enter. Okay, let's take a look at the quartiles. Now, these quartiles are kind of cool. Okay, I'm going to put equals, and then we have start typing the word quartile. So it does not matter if you're using EXC or INC. It doesn't matter. You're going to get the exact same values. So I'm going to click on that. So quartiles, you start typing in quartiles. I have quartiles right there. The next thing, it'll tell you what you need to put in this box. It says array. Array is all of my data. So I'm once again highlighting all of my data. all of my 137 data values. There we go. So I highlighted all of those in there. I'm going to hit enter. I know, okay. And then after I put in my data values, I put comma, and then I tell it which quartile I want. I want the first quartile. So I put 1, close the parentheses, hit enter, bam, it gives me Q1. Q2 is median. So I'm just going to once again put median in there. So you don't have to do quartile 2 because quartile 2 is just median. So for quartile 3, enter or equal, start typing in quartile. Once again, we want this whole array. You just highlight the whole thing. Highlight the whole thing, and then comma, I want quartile 3. Close my parenthesis, hit enter, bam. I've got my quartiles. Finally, we are going to calculate our IQR. So click on this box. We're going to tell it to do math. So I'm going to click on this box because I want Q3 minus Q1. Click on this box, hit minus, then click on this box. It's going to tell me to subtract box F33 from F35 and hit enter, and it calculated my IQR. Are there questions so far before I do number 2 and 4? All right. Okay, so number 2, what this is asking me is, do I have any outliers? There's a couple of different ways you can do this. You can either take your highest value and your lowest value. I just did it backwards, highest value and lowest value, and you can calculate those z-scores. Or you can determine where 2 standard deviations above your mean is and where 2 standard deviations below your mean is, and you can determine, your upper boundaries. I'm going to show you how to do the math in Excel. Now for number 2, I'm not requiring you to do the math in Excel. I like to do it because it's Excel and Excel is fun. So I'm just going to type words first. I'm going to do upper limit, type in the words upper limit, and that'll be my upper z-score. So I'm going to do equals my mean plus 2 parentheses, standard deviation. Yeah, what did I do? Okay, I forgot to put it wants the asterisk for your, I'm going to redo this, equals the mean plus 2, it wants the asterisk for times, there we go, this box, enter. So that calculated my upper limit. I'm going to type in lower limit equals the mean minus 2 times the standard deviation and hit enter. So this gives me my lower value and my upper value. Any value higher than my upper limit would be an outlier. Anything lower than my lower limit is an outlier. You see that I have some outliers here. So after you find those upper and lower limits, I want you to just type in here, I have outliers. I do. Do I have any up here? I have one up here, I think. Let me see. Up here, I have 9.3. That's an outlier. 9.3 is an outlier, and 4.4 and 4.7 are outliers. So I would just mention here that, yes, I have outliers. These are what they are. Or you could say, no, I don't have any outliers because nothing lies because the z-score of my lowest value is 1.8 or negative 1.8, and my z-score of my upper value is 1.2. Therefore, I have no outliers. So I want you to at least bare minimum tell me what the z-scores are of your upper and lower and determine if they're outliers. Or you can do this and say, based on this, I have outliers. Questions on that? Okay. The final piece, number 4. All I'm asking is for you to look at your mean and look at your median and tell me, based on their relationship with each other, do you have, or is this skewed left, right, or is it symmetric? Notice mine. My mean is 7.05 approximately, and my median is 7. Those values are really close to each other. Therefore, my data is not skewed. It's symmetric. So you would have different based on yours, right skew, left skew, depending on if your mean or your median are bigger or smaller. So you might want to open that page in your notes and look at the comparison. So you're just typing that in. You're not using you're not using your descriptive statistics at all. You're just mentioning based on how close your mean and median together, whether or not it's skewed. All right, that's it on the lab. Any questions? Right. That's all I have for you guys tonight. Fantastic. I'm really excited to see I believe the hand and homework's due tonight. I will try to start grading it tomorrow. I won't guarantee it will be fully graded until maybe Thursday or Friday, but I will start grading it tomorrow, hopefully get it done pretty quickly. So I'm looking forward to seeing the hand and homework come in. I think tomorrow or Thursday, I will send out the practice test. The practice test has no content in it. It's nothing. I mean, if you can do 2 + 2, you can do the practice test. So it's just basically for you to download the Respondus lockdown browser and test it, because it would be really terrible if you got to the actual test and the lockdown browser didn't work for you and weird things happen. So all it is testing the software, and you get a few extra credit points. Who doesn't like a few extra credit points? Yeah. All right. So any questions for on the recording? Okay, I'm going to stop the recording.